For example 3, it says, under what conditions will the following cusp be produced in terms of f of a, f prime of a, and f double prime of a? Well, what do we know about the value of f of a at this point? Well, we know it's above the x-axis, so we're going to say that f of a is greater than 0. Based on what we discussed, it's not a gradual change in slope. It is going down to the vertical point there, which means f prime of a does not exist. And if it's a value that doesn't exist in the domain of f prime of a, it can't exist in the second derivative. We also can see that there is a slope downwards towards a, and there's a slope upwards away from a, meaning that as f prime of a is approaching a from the left, it's going to be negative, and as it's approaching a from the right, it's going to be positive. We can also see that it is concave down here, and it is concave down here. Which means that f double prime of a from the left is less than 0, and f double prime of a from the right is also less than 0. So as it says, the above is one example of a cusp. The proper definition of a cusp is an extreme case of a corner. A corner occurs at a point where the left-hand derivative and the right-hand derivative are not equal. A cusp occurs at a point where the left-hand derivative and the right-hand derivative are not equal, and the left-hand derivative or right-hand derivative equals positive or negative infinity. There are several ways that we can have this happen. We can have a vertical cusp, kind of like what we just took a look at, where a vertical cusp can look like this, where we can see that it's going from concave up to concave up. We can have a vertical cusp that looks like this. Where it's going from concave down to concave down, like in the example that we just saw. But we can also have what's called a blunt cusp, which we haven't encountered before. A blunt cusp can occur from going concave up to concave down, or it can occur from going concave down to concave up. So we can see that it can be concave up, concave concave down, or concave up to concave down to concave up. The biggest thing is that we have a sudden change in our slope. It's going from positive to suddenly being negative without a gradual change. It's going from negative to suddenly being positive without a gradual change. And the same thing occurs here. It's going positive up to an extreme positive, so positive infinity, and then suddenly shifts and starts going negative, or is negative, and then suddenly shifts to start being positive.